And here's a second example of Newton's first law. Here we have a person walking, and maybe I should draw the ground so that we know it's not elevated up in the air. So we have a person walking on the ground carrying a package. So let's say they're carrying a box and carrying a box across the room like that at a constant speed of 1 meter per second. And the question would be, what would be the net force on the box, realizing since he's moving at a constant speed of 1 meter per second, there's no acceleration. And of course, using Newton's second law, we know that F equals ma. Let's write that down. F equals ma, and if a is 0, then F has to be 0. And of course, we're not about F period, we're talking about the net force must equal 0. So it's always a good idea to put the word net there, realizing there may be forces, but they should cancel each other out if there's no acceleration. So let's look at all the forces on the box in the vertical direction. Well, we definitely do have the force due to gravity, downward like this. So F due to gravity is equal to the mass of the box times acceleration due to gravity, which is of course downward. And then of course, since the hand is right there, if you pull the hand away, the box will accelerate downward, but the hand is giving it the reactionary force, the normal force to the box. So normal force, which is equal in magnitude, opposite in direction, that's Newton's third law, and so the two forces cancel each other out. So in the y direction, the vertical direction, there's no net force. But what about the horizontal direction? This is where Newton's first law comes in. Surely you think, that's intuitive, that when you carry a box across the room like that, that you're pushing the box forward. But Newton's first law says, no, not really, because Newton's first law says that once the box is in motion, once the box is moving along with the person at 1 meter per second, it takes no additional force to keep the box going. Remember, unless some force comes along to change it, that box will continue moving forward at 1 meter per second forever. The hand is merely there to keep it from accelerating downward. So other than that, once the box is moving, the hand is not pushing the box forward in any way, shape, or form. So that means in the horizontal direction, there's absolutely no force acting whatsoever. Wow, that's interesting. So if that's the case, we can say that in the horizontal direction, we can say that F net in the x direction is equal to 0, and period, any force in the x direction is equal to 0. So therefore, we can say in the x direction is equal to 0, in the y direction is equal to 0, so there's no net force on the box, so there will not be any acceleration in the y direction, and there will not be any acceleration in the x direction. And if it wasn't for Newton's first law, we probably would never think of looking at it in that fashion. So thanks to Newton's first law, we realize now no force is required to keep a box moving horizontally at 1 meter per second.